Today we are learning compositions of transformations. So all that means is that we're going to do more than one transformation on each graph, which in this case, I believe all of yours are 2 in 1 graph. So the first thing we're going to learn is called a glide reflection, and all of your compositions of transformations must be done in the order that they give them to you. They cannot be done out of order. You will get the wrong transformations. Glide reflections, they must be done in order. In order for you to be able to perform a glide reflection, the line of reflection, so like in this first one, the line of reflection is of course the y-axis, and the second one it's the x-axis. So the line of reflection must be parallel to the vector. So all that means is, in this first case, if it's y-axis, so that's up, down, right? Well, whenever it's 0, 4, that means that you're going to make it go up 4, which is still up, down. So up, down line and up translation. So those are parallel. With this other one, it's x-axis, which is left and right, and -2 means it will go left 2. So since both of them are left-right, they can be done. In your book, it'll tell you whether it's a glide reflection or not, but I believe one of your homework questions asks you to write about it. So I just wanted to make sure that y'all understood that if it is a right-left translation, it's got to be x-axis. If it's an up-down translation, it's got to be y-axis. Okay, so the very first thing we have to do, and honestly this would be easier if you guys use the colored pencils or markers rather than using your pencil, because you can see which one did what. So the very first thing we're going to do is we are going to translate JLK up 4. So we're going to take each of those points and move them up 4. So J will go 1, 2, 3, 4. So this will become my J prime. K will go 1, 2, 3, 4. So this will become my K prime. And L will go up 1, 2, 3, 4. And this is my L prime. And then connect the dots. So my original, as far as coordinate notation is concerned, is x, y. And then whenever we moved it, our x's didn't change at all, but our y's went, we added 4 to all of the y's. Okay, the next thing we're going to do, we are going to go off of the red one. So forget about the black one, it is now gone. And we're going to reflect the red one across the y-axis. So L is 1 to the right from the y-axis, so we're going to go 1 to the left. And this will become L, and since this is the second time we've moved it, this is L double prime. So there's 2 primes, 2 apostrophes. J is 2 to the right of the y-axis, so it will go 2 to the left. Therefore, J is right here, and this will be J double prime. K is 6 to the right, so K will then be 6 to the left, and that will be K double prime. Straight lines are hard to draw. And that's finally what it looks like. And the way on a y-axis reflection, don't forget that the x is what changes signs, and then the y stay the same. So all of it, it's easier if you color code it so that you can see exactly what you did for each one. On the second one, we're going to translate it 2 to the left. That's what that says. So Q2 to the left will be here, and that will be Q prime. R2 to the left will be here, that is R prime. P2 to the left is right here, that will be P prime. And for our coordinate notation, our original is XY. And when we move it 2 to the left, that means we're subtracting 2 from our x's and our y's stay the same. And then we have an x-axis reflection. So that means that however far above the line it will be that far below. So P prime is 1 above, so it's going to go 1 below to make P double prime. R. R is 2 above the line, so it will be 2 below the line, so it'll be R double prime. Q is 5 above, so it will be 5 below. And that will be Q double prime. And then connect your dots. I am also going to post this video on my website, so y'all are welcome to go there to watch it as well if y'all need like a little bit of a refresher later. Oh, I forgot to say how that one moves. So an x-axis reflection is your x's stayed the same, but your y's change signs. These next ones are not considered, they're just compositions, so it doesn't really matter. They're just more than one transformation on a graph. You don't have to know any specific, they don't have to be parallel or anything like that. You still have to do them in order. So we have to do our y-axis reflection first for this one. So however far to the left of the y, that's how far it should be to the right. So this should be 1, 2, 3 to the left. So we're going to go 1, 2, 3 to the right. And that is now D prime. C is 7 to the left, so it's going to go 7 to the right. And that is C prime. And then connect your dots. That is your y-axis. Now we will do a 90-degree rotation. Oh, I forgot to write how it changed. So X, Y. And then y-axis reflection, your x's change lines and your y's stay the same. Now we need to do the 90-degree rotation. So our original points for D prime and C prime is at 7, 1. And D prime is at 3, 2. So now, if you want to do a 90-degree rotation, you can make this the top, and you can look at it from that direction. Again, I cannot physically turn my screen so that I can show it to you guys, but that's how you would plot it. So if this is the top, then you would go right 7 and up 1, and that would be your C double prime. And then you would go right 3 and up 1, 2, and that would be your D double prime. But if you don't want to have to figure out how to turn your page and all of that, you can, of course, just remember how your actual points change. Where is my point? I can't see my dot. I apologize. So C double prime is now at -1, 7, and then D double prime is at -2, 3. So what really happened is that my x's and y's flip-flopped, and then my y's became negative. So it's negative y x. Okay, on this one, it is a translation. We're going to move it right 3 and down 1. So C will go right 1, 2, 3 and down 1. This will become C prime. And then A will go right 1, 2, 3 and down 1. This will become A prime. B will go right 1, 2, 3 and down 1, and this will become B prime. And then connect your dots. Whoa, that's supposed to be a straight line. So your original notation is just XY. Whenever you have a translation with the vector 3, -1, you are adding 3 to your x's and subtracting 1 from your y's. Now we're going to take our red one and we're going to reflect it across the x-axis. So C prime is 2 below, so C double prime will be 2 above. A is 1, 2, 3 below, so it'll be 3 above. And then B is 6 below, so it will be 6 above. And then connect the dots. And x-axis reflections negates your y's. Next, we have to find the preimage. Now this one can be kind of confusing, so you guys need to make sure that you pay attention to what I'm doing here. The first thing that you have to do is you're going to graph the transformations in reverse. Because what's happening is they show you what it looks like after they have moved it twice. They want you to figure out what it looked like originally. So you're graphing the transformations in reverse. Okay, so you're graphing the transformations in reverse. So instead of going top down, you're going down up. And you're also going to do it the opposite way. Unless it's a reflection. That is the only time that it won't be an opposite way. Reflections will just be reflections. There is no opposite to an x-axis reflection. But if the original told you to go right 3 down 1, then you're going to go left 3 up 1. So that will change directions. Also on a rotation, you usually go counterclockwise. In this case, you're going to go clockwise. So those are the way that they will change, but reflections will not. The other thing is whenever you write coordinate notation, it will go in the correct order because coordinate notation will always be in the correct order. So write coordinate notation in the correct order. And of course, I will show y'all examples of all of that. So the first thing that happened to this picture is it was reflected across the x-axis, then it was reflected across the y-axis. But we have to do this in reverse because this is the order that it went originally. Well, we have to go backwards to figure out what the preimage looked like. So we're going to do a y-axis reflection first. So anything to the left, that's how many to the right it will be. So A double prime is 1 to the left. So A prime, because remember we're going in reverse. So double prime turns into just a single prime. That is A prime. D is 1, 2, 3, 4, 5 to the left. So it will be 5 to the right. That will be D prime. B double prime is 2 to the left. So B prime will be 2 to the right. And C double prime is 1, 2, 3, 4 to the left. So it will be 1, 2, 3, 4 to the right for C prime. So just reverse order from whatever it gives you. Next, we will be reflecting it across the x-axis. So A prime is 1 below. That means that A, because remember we're going in reverse, so A prime turns to the original A. D prime is 1 below, so D will be 1 above. B prime is 1, 2, 3, 4 below, so it will be 4 above. C prime is also 4 below, so it will also be 4 above. C will be 4 above. And that is what the original looked like before he ever moved it. So from our original, because our original now is blue, our original is just XY. And then to get to the red one, to get from blue to red, we actually reflected it across the x-axis. So whenever it reflects across the x-axis, to get from blue to red, you change the sign of the y. And then to get from red to black, we reflected it across the y-axis. So that means you change the sign of your x's. So this is in the order that the transformation was actually performed. This should be just your regular letters. This one should be your prime letter, and this one should be your double prime letter. So that's what it means by writing coordinate notation in the correct order. All right. So now, this next one, it was rotated 90 degrees and then reflected across the x-axis. So in reverse, we're going to reflect B, C, and D double prime across the x-axis to get B, C, and D prime. This B double prime is for above the x-axis, so we're going to go for below the x-axis. B prime. C double prime is 5 above the x-axis, so we'll go 5 below to be C prime. And then D double prime is 2 above, so D prime will be 2 below. All right, then we're going to have to reflect it 90 degrees, but originally went 90 degrees counterclockwise, so we're going to have to go 90 degrees clockwise, because that is the opposite way. So our B prime, C prime, and D prime. B prime is at -4, -4. C prime is at -2, -5. And D prime is at 1, -2. So whenever I replot it and it goes 90 degrees clockwise, so that means that this will rotate around this way. It'll end up here. -4, 4. -4, -4. There we go. -2, -5. That's B. This is C. And then -1, -2. That's D. Or you can just remember that the X's and Y's flip and the X's become negative, just like we had originally talked about in class. So their very first, the non-primes, is XY. And then to go to the prime, we rotated it 90 degrees. He rotated 90 degrees counterclockwise. So to go from this blue to this red is a counterclockwise rotation. And in order to do that, to get from C to this C, that was -5, 2. And this C is, C is -5, 2. And then C prime is -2, -5. So my Y turned negative and my X stayed the same. And again, if you memorized it, that's great. You can just write the memorization that you did. I personally can't memorize that. It is too hard. So I just literally turn my page every time. Or in this case, I turn my head to where it looks at the page sideways. And then an x-axis reflection, your Y is turned negative. So we are done with this one. Again, you can rewatch this on my website. If you're having a hard time with it, rewatch it again, and hopefully it'll make sense. If not, you can always come to my tutoring or talk to me before school. This stuff is not going to go on this 9 weeks. It's going to go on next 9 weeks. So you still have time to understand it. And I will see you guys on Friday.